Welcome everyone. Go ahead and go grab your math review work from yesterday so you can self-assess your work. Alright, let's start with our first question. It's a place value question related to rounding. Let's go ahead and read it. Which number would be 18,000 when rounded to the nearest thousand? Okay, so I know that it's kind of working backwards. We want to round. It's going to round to 18,000 when rounded to the nearest thousand. So I'm going to look at my choices and I'm going to underline the digits that are in the thousands place and the hundreds because I know the hundreds place will tell me what to do. Alright, so let's go ahead and take a look at these. We have the 7 and a 4 here. I know that 4 is going to make the 7 stay there, so that rounds to 17,000. That 5 is going to make the 7 round up because we're close to regrouping. So we are at 18,000 here. That seems like the right answer, but you always want to double check. That 6 is going to make that 8 round up to 19,000, and that 8 is going to make that 8 round up also, and that number is going to round to 19,000. So our best choice is B. Go ahead and give yourself a check if you got it right, or make revisions if you have it wrong. Alright, our next problem has to do with our area model. Know that I really miss showing you guys this back at school. So we have 54, which we know we can decompose as 50 and 4, and we have 25, which we can decompose as 20 and 5. So we're giving each digit its value. So let's start organizing our work. So I'm going to put 50 and 4 here. Well, you know what? Let's do 20 because this is more proportionate. So we have 20 and 5, and then we're going to have the 4 and the 50. Okay? So we're going to start finding the area of each of these rectangles. So we have 20 times 4, which is 80. And then we have 5 times 4, which gives us 20. We have 20 times 50. 2 times 5 is 10. And then we're going to add the 2 zeros because we're really multiplying tens. So we get 1,000. And now we have 5 times 50. 5 times 5 gives us 25. But I'm going to add a 0 because I'm really multiplying 50. Alright, so here are our partial products. All we're going to do now is add them up. So I get 1,000, 250, 80, and 20. Okay. So I'm going to line them up vertically and now I'm going to add them. 0, 0, 0, 0. 8 and 2 gives me 10 plus 5. We get 15. Regroup the 1 over. I like to circle the digits that I'm regrouping. That way it just makes it easier for me to understand what I'm doing. So I have a 2 and a 1, which is 3, and 1,000, and there's nothing else in the thousands place. So you get 1,350. Go ahead and give yourself a check if you got it right, or stop the video and make some revisions. Okay, we're up to the next one. Wendy has a rope. Well, let's make sure you guys can see it. There we go. Wendy has a rope that is 132 inches long. If she cuts the rope into 6 pieces, how long will each piece be? So I see that we have a total. The rope is 132 inches long, and she's gonna cut the rope into 6 pieces. So we know the number of groups, but we don't know the group size, which is what we're finding. How long will each piece be? So we have 132, and we are going to be dividing it by 6. So I ask myself, how many groups of 6 can I make if I have 13? Well, I know that 6 times 2 gives me 12, so that means I can make 2 groups. 6 times 2 is 12. We're going to find our remainders. 13 minus 12 gives me 1. Regroup the 2 over here. Oh, and there we go. I know that when I multiply 6 times 2, that gives me 12, which means I can make 2 groups. 6 times 2 is 12 minus 12. I get a remainder of 0. So here is our quotient. And now we know we can do the inverse operation to do a check. So we're going to take 22 times 6. 6 times 2, 12. Regroup that. 6 times 2 is 12 plus 1, 13. And that matches our initial answer, so we are correct. Okay guys, we're ready to move on to our fraction question. And I just want to mention, I'm sorry if you printed this, the shaded parts didn't print. And also I just want to mention, like, these bars over here are not exactly proportionate, so I just want to apologize about that. My husband, who's a math teacher, he was very upset about it, and I can understand. So let's go ahead and figure this out. This question says circle the two figures that are equivalent to one another. So first, what I want to do is I want to write the fraction for each of these models. So this has 6 parts shaded out of 8 parts in total. This has 2 parts out of 3 parts shaded. This has 1 out of 4 parts shaded. And this has 3 out of 4 parts shaded. So looking at this work, I already know that I can eliminate 1/4. I know that 1/4 is less than a half, and this fraction is more than a half, so is this one, and so is this one. So this one we can completely eliminate. So I'm going to try out 6/8, and I'm going to see if that is equivalent to 2/3. We'll see that. We can give each of these fractions. So we're dealing with an 8, we're dealing with a 3, we're dealing with a 4. I mean, we could always just rename all of them to have a denominator of 24. That could be something we can do. So let's do that. So to get from 8 to 24, I would have to multiply times 3. 8 times 3 gives me 24. 6 times 3 gives me 18. So I get 18 out of 24. And let's do that down here. Okay, 3 times 8 gives me 24, and 2 times 8 gives me 16. So I get 18 out of 24 and 16 out of 24. I can see already that these two are not equivalent. Alright, so to get from 2 to 24, I'm going to multiply times 6. Whatever I do to the denominator, I'm going to do to my numerator. 3 times 6 gives me 18. So I can see that this fraction and this fraction are equivalent. 18 out of 24 and 18 out of 24. So we're going to circle those two as equivalent. Alright, let's go ahead and move on. Alright, this is very important because we just had a post-assessment and a lot of us really struggle with these line plot questions. So let's take a look at it. It says, what is the total length of all the vegetables that measure 7/12 of a foot? So if I'm thinking about 7/12 of a foot, and by the way, this is all the lengths of vegetables. See a line plot there. So all the vegetables that measure 7/12 right here, we have 1, 2, 3, 4 vegetables that measure 7/12. So we're doing 4 times 7/12. Okay, I can multiply a whole number times a fraction by giving the whole number a denominator of 1. And I'm going to multiply it across. 4 times 7 gives me 28, and 1 times 12 gives me 12. So let's leave it as that, 28 over 12 feet. Okay? Alright, let's go to the next problem. How many 1-degree angles are shaded in the sheet below? So it's a circle, which I know measures 360 degrees. I have 3/4 of it shaded, so I know that's the same thing as saying 90 plus 90 plus 90. So I have 180 plus 90. This is 270 degrees shaded. Go ahead and give yourself a check in those two problems if you got them right, or make some revisions if you have to. Okay guys, so we're continuing to our POD now, and like I mentioned before, we're going to be doing a lot of work with line plots because that was a question that we missed on our state test. I'm sorry, on a post assessment. So we just want to make sure that we understand it. So let's start by reading this this little blurb up here. A scientist measured the length of 12 beetles to the nearest 1/8 of an inch and recorded the data. So here are 12 beetles, and here is the data. And I know data is an academic vocabulary that just means the information, the numerical information. So here are the beetles, and here's what they measured. Okay, now let's see. Part A says use the chart to create a line plot. Alright, so I know part of the line plot, one of the things that the line plot needs is a title. So I'm just going to give it a title. So this has to do with beetles and their measurement. So maybe I can say beetle length. Okay, and then I'm gonna make a line down here, and I'm going to label this with the units. So I'm using length, and the chart tells me that I'm measuring with inches. So I can say inches in parentheses. Now I take a look at my data, and I notice that I start at 1/8. That's the smallest fraction that I have here. So I'm going to start at 0, and then I'm going to label 1/8, and then 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8 out of 8, which I know is also equal to 1. So I'm just going to write that in parentheses as 1. Alright guys, tomorrow we're going to continue with this line plot, see what you can do, start filling it in. And I just want to say, like, take a look at this. We have 1/2, And then we also have 1/4. Although we don't have that down here, I know that a half, that's easy to find. Half of 8 is 4. So 1/2 is going to be right here. Okay. And what about a fourth? I want you guys to think about it. This is a denominator of 4 and that's a denominator of 8. So where would 1/4 be? All right, good luck everybody. I'll see you tomorrow.